And let's start with exercise number 2 from PDF file that I have just sent in Telegram chat. So first will be number 2. Number 2. According to the condition, during time tau, during time tau, a point traversed a half of a circle of radius r. Radius r. In the first part, it is necessary to find average value of modulus of velocity. In first part, in part A, it is necessary to find average value of modulus of velocity. So it is necessary to find this average value of modulus of velocity. Maybe you have any ideas, or maybe you have some ideas about how to find this average value of modulus of velocity.
How?
This value is the same as this. So it is necessary to find formula from our previous lessons, and use this formula here. But first of all, it is necessary to find it. But modulus of average velocity is always equal to full path length divided by full period of time. So it is something like this: delta s is path length divided by delta t, path length and time. And can we find these values in numerator and denominator? So can we find delta s and delta t according to the condition of the exercise? So maybe I will draw a picture. To make the situation clear. So according to the condition, a point traversed half of a circle. So the trajectory is half of a circle, and I'll set some reference system. We can do it in any way, but in this case, it is useful to choose coordinates as it's shown on picture. in way shown on picture. So x axis, y axis, origin O, and the trajectory is half of a circle. Half of a circle. So I have to remove lower half of a circle. Here. Okay, so this is our trajectory. And path length is length of this trajectory. So can we find delta S according to this picture? If we have, according to the conditions, that radius is equal to r. So can we find, according to this picture, delta S? Okay, if delta S is length of this, length of the path. How to find this? Can you remember?
It is just the length of the circle, half circle.
Half circle, yes.
So 2 PR and whole circle, it must be PR.
Yes, it will be PR. It will be just PR. Okay. It will be just PR. So this is half of a circle, PR. So this is path length. Okay, and what about delta T? It is necessary to read. It is necessary to read the condition carefully, and if you do it, we will find delta T here. In the condition.
During the 3 point traverse the half of circle, so less than 180, so every exertion. Do we have any alpha or something like that degree? Do we have any degree? No.
According to the condition, we have during time tau.
Okay, if I have a guess, 180.
180.
It's a degree. Am I right?
But we need time. We don't need angle.
We don't need angle. It's a, okay, I don't know.
According to the condition, we have during time tau. So it is time tau. It is time, so we can write delta t is equal to tau. So according to this, we have PR divided by tau. So this is the answer for the first part of the exercise. Okay, do you have any questions about this?
No, it's better right now.
No. Okay. Okay. Okay, then let's do the next part. In the next part, it is necessary to find the modulus of average vector of velocity. So in part B, modulus of average vector of velocity. So it will be something like this. Modulus of average vector of velocity. Okay, and what to do in this case? Maybe you can remember some formula from our previous lessons.
Oh, I must check all of them. Let me check.
Okay, so it will be if average modulus of velocity was path length divided by time. And in this case, we need average vector of velocity. So it is necessary to divide displacement vector by time. So delta t we have before. And what about displacement vector? What about displacement vector? How to find it? I will draw this picture again. I'll draw this picture again, and we don't need this. We don't need this, so I have to remove this from the screen. I have to remove this. Okay. So I have drawn a picture again, and now it is necessary to do the first step. It is necessary to show displacement vector on this picture. Displacement vector delta r. And to do this, it is necessary to remember what displacement vector is. What displacement vector is? It is a vector that connects initial and final position of material point. So displacement vector begins in initial position and ends in final position. And initial position was here, and the final position is here. And it means that we can draw displacement vector in this way. We can draw displacement vector in this way. So it is here, displacement vector. But to move forward, we need to write displacement vector as formula. We need to write this to define this analytically. To define this analytically, so what can we write here? I mean that it is necessary to write vector delta r as this. So it is necessary to write delta r in this way. So it is necessary to write delta r with components of vector and with orts I, J, K. Okay, and can you remember how to draw orts I and J on our Cartesian coordinate system? Okay, it will be here. So what problem with this? It will be somewhere here. So and then we have here we have I and J, E and J, ort E and ort J. And according to the picture, what will we get for delta R? What will we get for delta R? Okay, and okay, what can we say about this length? What is the problem with this? Oh, what can we say about this length? Oh, that's bad. What's wrong with this? And oh, I will do this. Okay, what can we say about this length? About this length, I mean, according to the picture. So this is the length
Double
of
R.
yes,
Double R. It must be double R.
double R. Of
2R.
course, it is double R because this is length of diameter. This is length of diameter. this is length of diameter, so it will be double r. It will be double r. And because of this is double r, and we can see the displacement vector is directed the same as axis x, and this picture means that delta r delta r displacement vector will be 2r multiplied by ord e plus 0 multiplied by j and plus 0 multiplied by k. Yeah, because there are no components of vector delta r that are parallel to axis y and axis z. So we have 2r vector e. 2r vector e. R and vector e. Okay, and do you have any questions about this?
No.
No.
Actually, it will be fine at the end of the question, I think. Right now, it's okay. So far, so good.
Okay. Okay. If it is good, so let's substitute this in our formula. So we have 2r e divided by, and what can we write instead of delta t? In the same way as it was before. In the same way as it was done before. Delta t is equal to tau. Delta t is equal to tau. Okay, and how to get modulus of this vector? It is necessary to remember analytical geometry and vector algebra. So c is equal to modulus of vector c. It will be square root cx to the power of 2 plus cy to the power of 2 and plus cz to the power of 2. So according to this relation, we can write that it will be square root of double r divided by tau. And this is to the power of 2. To the power of 2. Okay, and if we get this square root, we will have that it is equal to 2r divided by tau. to r divided by tau. Divided by tau. And inside the modulus, all values are positive. All values are positive, so it means that we can write double r divided by tau. Double r divided by tau. Okay. Do you have any questions about this?
Yes. Let me check.
Okay. And the last part of the
Okay.
exercise, part C. Part C, where it is necessary to find the modulus of average vector of full acceleration. Modulus of average vector of full acceleration. If tangential acceleration is constant. Tangential acceleration is constant. So we have one more condition. So that a tau, tangential acceleration, is equal to some constant. Tangential acceleration is equal to some constant. Is equal to constant. Okay, and I think I will draw this picture again. But first of all, it is necessary to find average modulus of average vector. So it will be this modulus of average vector of acceleration. And how to write this? It will be something very similar to this. Do you have any idea?
Uh, 2pr divided by 2 square. Power of 2. Tot power of 2. It must be.
And
Mm.
how
So,
do you know
total,
this?
total to divided. it-
But
It's like, yeah.
it is a good idea, but it is necessary to explain it.
Yeah, yeah. Yeah, so it must be delta velocity divided tau. So it's like, yeah, it must be something like that.
It will be delta V
Yeah, delta V divided tau.
divided by delta
Delta
T.
T equal to, yeah, yeah,
And
delta.
and delta T is equal to tau, Greek
Mhm.
letter. Okay, that's correct. That's correct. So here we will have. I will redraw this picture again because we need this to work with vectors. We need this to work with vectors. Oh, uh, but why this half of a circle appeared? Why did it appear again? I cannot understand. I cannot understand. Oh, this is good. And we can say that delta v is a change of vector of velocity. So it is equal to some final value minus initial value. Final minus initial. And here we have tau. Here we have tau. Here we have tau. And our next step is to show these vectors v2 and v1 on our picture. So how can we do this?
So, are you asking inside of the V2, V1? Am I right?
Yes, v2 and
Uh,
v1.
okay. PR divided by tau minus. Uh, let me. I was found before. Let me think.
We need to show this on picture now. First step is to show these values on our picture. So,
So PR divided by tau. PR.
but it will not
No,
be PR divided by tau
no.
because we have acceleration.
Yeah. So mm,
We have
generally acceleration formula. So I can say that 1 divided 2 multiplied A delta A tau minus, yeah. It must be give us velocity.
Mhm. Yeah,
It's it's a gen
I think we need first step is to understand
Mhm.
where will be these velocities on our picture. So velocity is always tangent to the trajectory. Is always tangent to the trajectory. So in initial point we have velocity v1 in initial point. And where will be velocity v2 in this situation?
Where?
Now, can you show on this picture velocity v2? I mean this, for example, the final position is here. Final position is here. So in this position,
2R.
we need to show vector v2. Vector v2. So and we need to show this on our picture. We need to show this on our picture. So it will be directed in some way like this. It will be v2. It will be v2. And our next step our next step to write these vectors with components in the same way as it was done here. In the same way as it was done here. So to write this in orders and components of vector. Okay, so vector v1 is directed vertically to the top of axis y. So it have only vertical component. Only vertical component this vector has. So it means that we can write that it will be equal to 0 multiplied by ort I. Ort I is here plus absolute value of v1 multiplied by y and plus 0 multiplied by ort key. And it will be v1 multiplied by y. v1 multiplied by y. Okay, do you have any questions about this?
I think it's okay.
Okay. Okay, so the next step will be to do the same thing for v2. And how to do this?
Tell me again, please.
How to do the same thing that it was done before for this vector according to the picture.
So it must be a minus g multiplied 0 plus v2 g minus plus 0 k equal to v2 g or minus g. v2 minus g. Because direction is reversed.
Direction is reversed. Yes,
Yeah.
of course. This is the key thing that direction is reversed. Direction is reversed. This is the key thing in this situation. So it will be 0 multiplied by I minus v2 y plus 0 multiplied by key. And it will give us minus v2 y. Minus v2 y. And let's substitute these values here. So it will be minus v2 y minus v1 y and divided by divided by tau. Divided by tau. And it can be written in simpler way. It can be written as minus 1 v2 plus v2 plus v1 v2 plus v1 multiplied by y and divided by tau. Divided by tau. Divided by tau. And it is possible to simplify. It's possible to simplify this. To simplify this relation. We can do the next thing. Absolute value of minus 1 multiplied by absolute value of v2 v2 plus v1 divided by tau and multiplied by absolute value of y. Absolute value of y. Okay, and what can we say about this? How to simplify this relation? So what about this? What about this multiplier?
It's about direction, I think. So if we use absolute, it is give just a volume, so it's not necessary, I think. So it give us one.
Yes, it will be just one, because it's absolute value. It's absolute value. It will be just one. Okay. And what about this?
It's also give us direction information. So it's mean one.
Yes, because the length of unit vector is always one. So we have just a simpler relation v2 plus v1 divided by tau. Okay, that's great. So our next step is to find these values, because we still don't know v2 and v1. So to do this, we have to use this condition, that tangential acceleration is some constant. Tangential acceleration is some constant. So we have to use this in some way. And what do you think? How can we do this? Okay, and what about I'll copy this. We will use this condition in our next step. We will use this in our next step. And what is connection between tangential acceleration and velocity?
It's derivation.
Yes,
Yeah.
yes, it's derivation. Of course, it will be derivative dv and dt is equal to a tau.
Acceleration. Mhm.
Okay, so we have got a simple differential equation, and we have to solve this. We have to solve this to get v as a function of time. To get v as a function of time, we have to solve this differential equation. What should we do to solve this equation?
We need to find. So we know the dt tau. So we need to find up final velocity. It must be sum of this velocity one, velocity two.
Mm.
So
I mean how to find v as a function of time. So how to solve?
from location. So we know the diameter. We yeah we know the length of the road. So
Yes, we know this, but we don't need to use this here. We don't need to use this here. Now it is necessary to solve this in the same way as it was done in calculus course. And to do this, it is necessary to separate variables. It is necessary to separate variables. Variables are here are t and v. T and v are variables. And to separate this, we can to separate variables. It is necessary to meet two conditions. The first condition is that different variables must be in different sides of equation. Now this condition is not true because in the left side we have both v and t. Okay, and the second condition, uh, it shouldn't be differentials in denominator. So this condition is also not true because we have differential dt in denominator. Okay, so how to separate variables in this case? It's necessary just to multiply left and right sides of the equation by dt. So dv is equal to a tau dt. So here variables are separated. Variables are separated because we have v in left side and t in right side, and we don't have differentials in denominator. So variables are separated. This is good. And when variables are separated, it is possible to integrate differential equation. It is possible to integrate differential equation. So we can write now that it will be something like this. Okay, and if we integrate this, we will get some undefined integration constant. You will get some undefined constant, and to avoid this undefined constant, it is necessary to set integral limits. It may be done. It may be done with using initial condition. And initial condition is that at initial time moment 0, we have initial velocity v1. So in lower integral limit, we can write 0 and v1. Because at initial time moment 0, velocity was v1. And in upper integral limits, we have to set any time and any velocity. And I will write this above the letters v and t to avoid the same letters in integrand and in integral limit. To avoid the same letters. Okay, so we have two integrals in left and right parts of the equation, and can we calculate these integrals? Now it is
Yeah, we
necessary
must.
to remember our calculus course.
So yeah, yes we can.
Okay, and how to do this?
So we try to calculate right side of two. Yeah, okay. 80 the what?
For example,
Uh,
this.
uh,
What will we have here?
yes.
Okay, so maybe you can remember something like this from calculus.
Yes, I can write if you want. V the what's the upper of the D meaning? DTV. So how can we say that? This one. Let me check.
To avoid the same letter, here and here.
Okay, okay. I'm okay. I
Just to
got it.
avoid the same
Okay,
letter,
okay. I got it.
because here we have symbol of
Okay,
variable,
I
and
understood right now.
here we have direct value of variable, so it is not the
Okay,
same.
okay, okay. So, velocity 1 minus velocity 2 dt parenthesis, it will give us left side, right side, a acceleration t minus acceleration 0 dt parenthesis dt. It will give us. So it's t minus, yeah, yes.
Yes, okay. A tau t. Okay, and in the left side,
It's also same, but we are using velocity right now here in this.
almost
uh,
the same,
Okay,
because it will
mhm.
be v minus v1. V minus v1. And from here we will get v minus v1 is equal to this. Okay, and this is a dependence of velocity on time. V is equal to v1 plus a tau t, a tau and t. And from here we can find that in final position we have velocity v2 in final position. So this means that v2 is equal to a tau multiplied by tau. Oh, sorry, v1. I have forgotten about this. v1 plus this value. Okay, do you have any questions?
Give me a second. Let me. No, no, yes. Yes. Okay, there is no question for me. It's clear. I
Okay, that's great. So we can write here that it will be something like it will be absolute value of double v1 plus a tau and tau and divided by tau. Yes, but it is not the answer, because we still don't know this, and we still don't know a tau. About a tau, we know just that it is constant. It is constant, but we don't know its value of this constant. We don't know value of this constant, so it is necessary to do something else. It is necessary to do some more actions to get rid of unknown values. and I think we can use this. We can use this, uh, and we can use path of our point. So we can use path of our point. So how can we connect path and time from here? What is the connection between path and velocity?
Path meaning always zero, I think that.
Uh,
Zero meaning beginning at starting time, beginning time.
yes,
Yeah.
it is equal to zero
Zero.
at initial time moment. Yes, but how to define this in any time moment?
Anytime you want. No, it
Okay,
no,
and
it
what
must.
is the
Yeah.
connection between absolute value of velocity and path?
Connection, acceleration, or location. It can be.
Uh, Acceleration was taken into
Yeah.
account
Okay.
here, but to use this, we have to write some definition of absolute value of velocity. We need one more formula that connects the change of path and velocity. So it is necessary to remember some formula from our previous week.
I must check. Give me a second.
So it is necessary to use your notes from a previous week and find appropriate formula from there. Okay, there was a formula V, absolute value of velocity, is equal to derivative ds dt. ds, ds by dt. So from here and here, we have that it will be ds by dt is equal to v1 plus a tau multiplied by t. Multiplied by t. Okay, we have one more differential equation. And it is necessary to solve this to get dependence of path lengths on time. So we have solved one differential equation here, and now it is necessary to do something similar to solve this. Okay, so how to do this? Okay, remember what did we do? What did we do before? And something very similar it is necessary to do here. So what step is necessary?
So PR divided tau. We need distance divided time. So find velocity plus acceleration t tau. So
Mhm.
It's a final. It must be final.
Um,
It's
maybe, but the first step, I mean that how to solve this differential
differential.
equation. First of all, we
No.
need to solve this
Yeah.
differential equation in
Mm.
similar way as it was
Mhm.
done before here.
Mhm.
Okay, the first step is to separate variables. We have two variables, s and t. Okay, and how to separate them? How do you think? Because now variables are mixed. They are
Oh,
mixed here, and we need to separate them.
yeah. If we can take an integrate of velocity, we can separate the equation. But
Mhm.
no.
And how did we do this here? I mean
Okay. So okay, just it just go to opposite of the equation. So it must be v multiplicate dt equal ds.
yes.
It
So
yes distance.
yes, just
Uh,
multiple left and right
uh,
sides of the
uh,
equation by dt. So it will be ds. It will be ds is equal to v1 plus a tau t, and multiplied by dt, multiplied by dt, multiplied by dt. Okay, do you have any questions about this?
no, it's okay.
It's okay. Good. And our next step is to integrate this. Is to integrate this. Oh, is to integrate this. So we will get to integrals. We will get to integrals, but now we still need to set integral limits. And what can we say about this?
0 to tau or dt. Yes, if it is dt, if we okay.
And here,
Also 0 to 2 pr.
okay, 0 PR. Yes, that's great. That's great. It's from 0 to PR. From 0 to PR. That's correct. So from here we can get that it will be in left side we have PR, and what do we have in the right side?
Right side, you mean? dt, at, what? 0 mean what is, v1 plus a to t t power of 2 divided by 2. Yes, it must be like that.
Yes, it will be something
Not
like this: V1
v1
tau
plus
a.
t t square divided 2.
Yes. Okay. Okay. It is from calculus, and now we can make one action. One action. We can transform this relation. We can transform this relation to get something like this. Double V1 plus A tau tau is equal to 2p r divided by tau. Divided by tau. So we have got such relation. We have got such relation, and we can use this here. We can use this relation here. As you can see, this is just what we need. Is just what we need here for to solve our problem. So this relation allows us to get rid of both unknown values. So it is interesting case. It is interesting case when one relations allows to get rid of two unknown values. So we'll get 2p r divided by tau to the power of 2. And this will be 2p r divided by tau to the power of 2. So this is the answer for the last part of exercise number 2. Exercise number 2. Okay. What questions do you have about this?
What question? Yeah, I need to memorize all of the formulas. So actually there are, it's simple. So on the other hand,
I think
uh I think
it is not necessary to
yeah.
memorize formula.
Yeah,
Uh,
actually it's most important thing of the beginning of the question. Understand the question. After that everything is will be fine. Mhm.
Okay, we need to know how to find formula, how to understand it, and how to use it.
Yeah, you're right.
So
Yeah.
these three steps: how to find, how to understand, and how to use. And if we if we know this, this is enough. And memorize maybe it's just for fun, and something like hobby. Uh, Memorizing formula. So okay, and I think it will be enough. And there is a way to improve to improve your final grade is to do homework. Uh, One more way to improve final grade is to do homework. And the homework for next lesson will be exercise number 1.
Okay, sure. Mhm.
Exercise number 1 from PDF file that I have sent at the beginning. So you can if you want, you can do this and send me send me in Telegram, and I will take this into account. It is for students who want to have a good grade at the end of the semester. If it is necessary just to pass the course, it is necessary only to visit lessons, and it is possible. It is not. It's possible do nothing. But for good grade, it is necessary to do something. To do
Okay, sure.
something, to take active part in solving exercises and to do homeworks.
So
Uh,
there is no any exam or something like that, just homework, question, more practice. Am I right?
uh,
No,
yes.
okay, okay, I understood.
So, for example, you have some bonus for this lesson because you were active. You were active, and one more way to get bonus is to do homework. Okay, do you have any questions?
Everything's fine. So far, so good. Thank you.
Okay, thank you for your attention, and I hope to meet you next week uh, when we will continue.
So goodbye. Have a nice day. Have a nice week, teacher. See you.
Have a nice day to you.